Exceptions are in fact objects, and in fact the exception object is defined and derived from system.exception. That is the base class for all the exception objects in .NET. And the .NET framework actually defines a pretty large number of exception classes. And for proof of that, let's just quickly jump over to the MSDN website and you can see what I'm talking about. This is the exception class definition here on msdn.microsoft.com. And if you do a search for system.exception, or if you go to the URL up there in the URL bar, you'll see the exception class. Now, as we scroll down a little bit, you'll see that just like other objects, there are constructors. In this case, we've got 4 different constructors, and there are some properties. So these are the properties that exceptions make available. There's data and help link and message, and we'll explore some of these later on as we go through the exceptions. But what I really want to point out is as we scroll all the way down, you'll see that system.exception is the base class for a pretty large number of exceptions throughout .NET. Look at how large this list is. This isn't even the complete list. This is a list of a lot of the exceptions that descend directly from system.exception, but the one that we're most interested in is right here, system.application exception. This is probably one of the most common exceptions that you will come in contact with as a C# developer. And in fact, I've opened that window right over here. So this is the application exception class. And this class encapsulates all the exceptions that are thrown when non-fatal application errors happen. So once again, we can scroll down. You can see that there's properties and there's all kinds of ways you can create application exceptions. But once again, we get down to the instance hierarchy or the inheritance hierarchy. You can see that a lot of other exceptions happen to descend from application exception. And this is true throughout .NET. You've got exceptions that are descendants of other exceptions. And you might be wondering, well, with all these different types of exceptions, is it possible to write catch handlers that only catch certain kinds of exceptions? So to catch specific exceptions, you can put inside parentheses for each one of the catch handlers the kind of exception that you're looking for. So in the case that you see here, I've got a try block where I'm going to try a whole bunch of code, and then I have several catch handlers all in a row. So I've got a catch handler for an exception that's divide by zeros. I've got a catch handler for an arithmetic exception. I've got a catch handler in case we run out of memory. There's all kinds of stuff that I can put here. And I could put a generic catch at the bottom of all this too that catches exceptions that don't get caught by these. So let's jump over to the code and see how we can handle catching specific types of exceptions. So here we are in the example. This is the exception object example. And I've got my program file open. And down in the snippets, I've scrolled to the exception object section. So let's go ahead and copy the setup code, and we'll paste that into main. All right, now let's copy the try and catch all the way down to the finally. Okay, and we'll paste that in. And you know what? Since we already know that the finally always runs, I'm just going to comment this line out. We don't really need it for this example. Okay, so let's comment it out. All right, so this is pretty much the same example as I showed previously. We've got 2 numbers. We've got x here, which is 10. We've got y, which is 0. We have an integer for holding the result. And you can see here that we're going to try to divide by 0. The only difference from the previous example is that here I'm now catching a divide by 0 exception. And this is an arithmetic exception. And since I know that it's an divide by 0 exception, I can say, hey, you tried to divide by 0. I can also write out members of the exception object that's passed in. Because when you catch a specific exception, you get an argument. In this case, I've named it E, but you can name it whatever you want to. This will be passed into your catch handler, and this is the exception object that caused the exception. So we can do things like introspect that object and see things like what the message that goes along with it is, and so on and so forth. So let's save this, and let's build. Okay, build succeeded. All right, let's go ahead and run it and try to divide by 0 and see what happens. Sure enough, you can see that you tried to divide by 0. Now that first sentence there, whoops, you tried to divide by 0, is what I'm writing out. And the attempted to divide by 0 string is being written out from the message property of the exception object. All right, let's go back to the code. Let's try something else. Let's copy this catch handler, paste it down here. Now, what I'm going to do is, instead of looking for a system.divide by 0 exception, I'm going to look for an arithmetic exception. So I'm going to hit dot, and scroll down here, and I've got an arithmetic exception right here. So now I'm going to save, and I'm going to build. And you can see that the build succeeded. And what I'm going to do is run this. Now, because I have the divide by zero handler already in place, that's the first one it's going to jump to. The exception is going to jump to the first catch handler that makes the most sense. So even though this is an arithmetic exception, it's going to jump to the divide by zero version because that's more specific to the kind of exception I'm seeing. Let's try something else. Let's take the arithmetic exception and cut it and put it in front of the divide by zero exception. Now, you'll notice that when I do that, I get a little red squiggle on the divide by zero exception. Let's see what that error is saying. It says, error, a previous catch clause already catches all exceptions of this or of a super type. What this basically means is, because divide by zero exception is a subclass of the arithmetic exception object, this is never going to be called. What's going to happen is a divide by zero exception is going to be thrown, but since it's a subclass of this guy right here, this catch block is going to catch all the math problems that might come up, including divide by zero. And since it occurs first, this code will never get executed. So the C# compiler is catching that situation for me and saying, hey, are you sure you want to do this? Why would you put in a catch handler that's never going to be called? So let's do this. Let's take that right line out, cut that line. Let's put that in there instead and see what the message is for an arithmetic exception. And let's just take out the divide by zero exception. So now I'm catching the more general case. I'm catching the arithmetic exception now, not just specifically the divide by zero, although divide by zero is an arithmetic exception. So let's run this. And you can see that we're getting the same message in this case. So even though we got an arithmetic exception, it knows specifically what happened. And the message in this case is an attempt to divide by zero. So by using the exception object, your code can look for and catch specific exceptions. And if you don't want to catch a specific exception, you can use the catch handler that just catches any exception that comes its way. This is a way for your code to be on the lookout for specific kinds of exceptions so that it can take corrective action and try to prevent the user from having a bad experience while using your program.